How much do you really know about black holes? And what would happen if you fell into one? Imagine drifting through deep space, scanning star systems in the hope of finding a new world where humanity could someday thrive. Your ship glides past nebulae and dead suns until something strange appears ahead of you. A distortion, a warping of starlight, like space itself, is bending inward. A black hole. And because you're the kind of explorer who doesn't back down from the unknown, you steer closer. After all, how many people can say they've seen a black hole up close? This is What If. And here's what would happen if you fell into a black hole. Despite the intimidating name, a black hole isn't just a dark void in the universe. Einstein's theory of relativity predicted how these cosmic beasts are created. When a massive star reaches the end of its life, it collapses inward. If the remaining core is at least 3 times more massive than our sun, gravity overwhelms everything. Atoms, particles, even the forces that normally hold matter together. All of it gets crushed into a single, unimaginably dense point. So no, a black hole isn't empty. It's a colossal amount of matter compressed into a space smaller than anything you can picture. Think about the sun. Its gravity is 28 times stronger than Earth's. Stand on it, theoretically, and you'd be 28 times heavier. Now imagine squeezing 4 suns into a sphere only 15 miles, 24 kilometers, across. You could drive across that distance in half an hour. Yet within that tiny space, you'd have the mass of multiple stars. The gravitational pull that would create? Extreme doesn't even begin to describe it. A black hole's gravity is so strong that not even light, the fastest thing in the universe, can escape it. That's why black holes are invisible. We detect them only by the violent gamma-ray bursts and energy they unleash as they devour surrounding matter. These emissions, which Stephen Hawking helped describe, now carry his name, Hawking radiation. Hawking also proposed something even stranger. The idea that black holes might connect to alternate universes. Which raises a wild question. If you fell into one, could you come out somewhere else? Every black hole has an event horizon, a boundary beyond which escape becomes impossible. From far away, it would look like stars are swirling into a glowing ring around a perfectly dark sphere. As you approach, gravity speeds you up at an alarming rate. That's the first major warning sign. If you fall feet first, your legs will feel a stronger gravitational pull than your head. Your body begins to stretch as the difference increases. Astronomers have a charming name for this: spaghettification. Stellar black holes, which span roughly 9 miles, 15 kilometers, and weigh up to 20 suns, would tear you apart long before you even reach their event horizon. So if you insist on taking this cosmic leap, choose a supermassive black hole instead. One weighing millions of suns. Their gravitational gradients are gentler at the horizon, meaning you'd actually cross it intact. Surprisingly, you don't have to travel impossibly far to find one. A supermassive black hole waits at the center of our Milky Way. It sits about 165 quadrillion miles, 265 quadrillion kilometers away, harmless to us, but undeniably massive. But crossing the event horizon is just the start of your problems. At the center of every black hole lies a singularity, a point where density becomes infinite and the laws of physics as we understand them collapse. If you reach that point, you won't survive. You won't even exist in any recognizable form. You'll simply become part of the black hole. But from the outside, your fall looks very different. To an observer watching from a safe distance, you'd appear to slow down as you near the event horizon. Your body would stretch, dim, and shift toward red wavelengths. Eventually, you'd seem frozen in place, fading into the darkness. You'd never quite appear to cross the boundary at all. Inside a black hole, space and time switch roles. Time stops. Space pushes you forward, leaving no possibility of escape. No more than you could reverse time itself. Even when the black hole eventually evaporates after trillions of years, releasing every particle it consumed, nothing would mark which atoms used to be you. But Hawking proposed that information might never be truly lost. He suggested that alternate universes could preserve every possible outcome. In one universe, you fell in. In another, the black hole never existed. And from the outside, no observer could know which reality was true until you crossed the horizon. If you crossed it in a universe where the black hole was real, that's the end. But in another universe, you'd still be alive, just impossibly far from home with no path back. Would you risk exploring that possibility? If the mysteries of black holes pull you deeper, your next hypothetical journey is on its way.